Today we're going to do kitchen biology, and I want to teach you about enzymes. Well, actually in this video, all I'm going to do is I'm going to show you how to set it up, and then I'm going to show you the results. To get the answers of how it really works, you have to go to Google Slides, a PowerPoint, and go through all the answers there. So all I'm going to do is just set it up, do the demonstration, and show you the results. Okay, here we go. We're going to do 4 little lab demos. One of them that I like to call, Who's Been Eating Beans? And the second one, Rotten to the Core. The third one is Jello or No. And the fourth one is Fizzy Spuds and Foamy Guts. So here we go. The first one, who's been eating beans? So I'm going to tilt the camera. I'll be right back because I'm doing this all by myself. I think you guys ought to know that doing a YouTube video for my students is about as appealing to me as being stung to death by killer hornets or eaten by zombie dogs. But anyway, here we go. All right, so this one is about pinto beans. Remember, all of these labs have to do with enzymes. So in a big broad answer, the answer is enzymes, but you don't know how they work. So we're gonna start off with a start solution. Can you see that? We're gonna start with a start solution, and I've been soaking pinto beans overnight like you would if you were gonna make soup. And then we also have one of our favorites, IKI indicator, a starch indicator. You've worked with that before in the biochem lab. So here's some starch. Here's a starch solution. And we're gonna put in some IKI, which you know what this does. Well, it turns black, right? Okay, but watch. When we add the juice from the pinto beans, watch what happens. Are you watching? Voila! It turns clear. You put in another drop, and it turns black again, but look, it clears right up. Another drop, and it clears up. Another drop, and it clears up. Put in 2 drops, and it clears up. So the question is, why do pinto beans need an enzyme to break down starch? There you go. Next one. Apples. We all know that when you cut an apple open, it doesn't take long for that cut surface to turn brown. It'll look something like that. It's kind of nasty looking. Overnight is what that looks like. So a lot of people will take an apple like this and they take some lemons and they squirt lemon juice on it or paint lemon juice on it like that. And then overnight, here's my apple that I cut and I poured lemon juice on it and just put it in here. But look at it. It didn't turn brown. So that's the one that was left out to the air, and this is the one that had lemon juice on it. Okay, almost everybody knows that. All right? But what happens when you take an apple and if you break, okay, here we go. So you put your thumb on it like this, you put your hand on it, and you break an apple in half. A broken apple, and you let it sit overnight. There it is. You can tell I broke this one because it's all zigzaggy. I broke this one last night, and look at it. That's what an apple looks like cut. It turns brown. With lemon juice, it doesn't turn brown. And when you break it, it doesn't turn brown. So what's going on with that? Why does lemon juice prevent the browning? And if that's so, then why does breaking an apple prevent browning? All right, demo number 3. This has to do with Jello. All right. So what I've got here is I've got canned pineapple. I've got cooked pineapple. I've got fresh pineapple and frozen pineapple. See? Frozen. Okay, and frozen pineapple. And what we're gonna do is we're gonna make up some Jell-O. And in this Jell-O, remember that Jell-O, if you remember your biochem stuff, Jell-O is a protein, all right? And so now what we're gonna do is we're gonna take this gelatinized protein, and we've got, actually I wanna put it in a different order. I want it canned, fresh, cooked, and frozen, all right? So this has to do with temperature, all right? So here's some canned pineapple and Jell-O, fresh pineapple and Jell-O. Here's cooked pineapple and Jell-O, and frozen pineapple and Jell-O. And we're gonna let that sit in the refrigerator overnight. Where is it? Oh, it's still in the refrigerator. Ta-da! Here it is. All right, here's the results. Cooked pineapple, set up just fine. There you go, cooked pineapple. But look what happens to the fresh pineapple. It didn't set. Something's interfering with the protein of the Jell-O. Here's canned pineapple, set up just fine. But look at the frozen. Now here's my challenge to you, is I'd really like you to try some different fruits. You know what happens with pineapple, but what about other fruits? What about cherries? What about raspberries, bananas? What about oranges would be good. Fresh orange versus a canned orange, like a mandarin. So why don't you try some different fruits? Make some Jell-O, get some little bowls, and try out different fruits, fresh, frozen, cooked, canned. Just put it in the microwave to cook it for a few seconds and see what happens with that. All right, fourth one. This one is fizzy potatoes or foamy guts. And what I've got here is potato and I've got liver. And I did the same thing. I cooked some potato chunks and I cooked some liver chunks and I have some fresh. And the other thing I have is hydrogen peroxide. Here we go. So you know what happens when you put hydrogen peroxide on a wound, all right? You know that you know that the hydrogen peroxide makes your wound fizz, all right? Here we go. Here's potato. All right. So that's raw potato. Can you see that it's foaming? All right. Now, here's raw liver. Woo! Look at that. Now let's look at the cooked potato and the cooked liver. There's cooked potato and cooked liver. Look at that. They're doing nothing. Fresh has something to do with making the hydrogen peroxide fizz, but the cooked can't do that anymore. So what's going on with that? To get the answers, you got to go to the PowerPoint. Google Slides. And there you have it, kitchen biology. Thanks, guys. Bye.